This video is going to cover Chapter 10, Lesson 3, and it'll be Day 2 because it's only going to focus on writing equations of hyperbolas. So just like before where we did with the parabolas and the ellipses, let's draw a picture. Let's give ourselves a visual. So I'm going to graph these x-intercepts. So I'm going to graph 1, 2, 3, 4, 1, 2, 3, 4. And I have a point here and here. And notice that it's touching the x-axis. So this is going to tell me that my equation is going to have the x squared first. Remember, the a squared is always the first denominator. And then the b squared will be second. Notice here, this is going to be, my center will be the origin. The way that I can tell that is that this distance from the center to each of the vertices is 4. It is also the midpoint between the two vertices, which happen to also be my x-intercepts. I'm also going to go ahead and graph the focus points. So I have a focus here at -5, 0 and +5, 0. The distance from the focus to the center, that's your C value. Doesn't matter if you do it over here or over here. When we're writing these equations of the hyperbola, what our goal here is to fill in our a squared value and our b squared value. Notice the only thing we have so far is we do have a squared because we have our a value, so we could square that 4. And I also have my c squared value. I can square the 5 and it becomes 25. But I need to find b squared. So what I'm going to use is the equation c squared equals a squared plus b squared. I'll plug in my c squared, which is 25. I'm going to plug in my a squared, which is 16. And I'm going to be solving for the b squared. So I'm going to subtract the 16. 25 minus 16 is 9. So my b squared value is 9. So now I'm going to take my a squared and my b squared and plug it into the equation. So I'm going to end up with x squared over 16 minus y squared over 9 equals 1. Let's try another one. Still with the center at the origin. So again, let's get a visual. Notice this time they gave me the two vertices. It's going to be on the y-axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm going to put a vertex here at 0, 6 and 0, -6. Now, again, we can see that because our vertices are on the y-axis, this tells me that the y squared is going to come first, then the x squared. And again, I need to find my a squared value and my b squared value. Now, from this graph, I could see that my center again is at the origin because remember, each of the vertices are going to be equidistant. Another clue would be if you have a 0 in your given vertice, then that's going to tell you that it's sitting on one of the axes, and in this case, the 0 is in the x spot. So this tells me where the number is, that's going to be the axis it's on. So again, that would tell me my origin is the center. So I have a center point of 0, 0. Now, I can also find my a value, which is the distance that the center is from the vertices, and that's going to be 6, whether I counted it down there or up here. So then this tells me that my a squared value is going to be 36. Now, this time I don't have a focus point, so I don't have a c squared value, but I was given an asymptote. And what you need to memorize is when the y squared is the very top variable in your equation, it's the very first one you encounter. The asymptote when the y squared is first is going to be plus and minus a over b. This is the format that the asymptote equation takes on. So let me go ahead and just take out this a over b and set it equal to the 1 over 2. Now, what we have to be careful here with is this 1/2 that's in our asymptote is a simplified fraction because we've already found our a value and it's 6. So let me go ahead and I'm going to change this a and make it a 6. So now the proportion that I'm going to solve is going to be 6 over b is equal to 1/2. Now, you could probably see that denominator without even solving the proportion is going to be a 12. But let's go ahead and solve it appropriately. 6 times 2, b times 1. So this gives me b equals 6 times 2, which is 12. So you can clearly see that 6/12 simplifies to that 1/2, which was in my asymptote. So now that I found that b equals 12, then I can square it, and b squared equals 144. Now I can go and plug everything into my equation. So y squared, and it's going to be over your a squared, which is 36, minus x squared over your b squared, which was 144. And that's your equation. Let's try another one. Again, let's give ourselves a visual. I have my 2 vertices, and they're going to be at 1, 2, 3, 1, 2, 3, at the order pair -3, 0 and +3, 0. Again, you can see your center is at the origin because that is the midpoint between those 2 vertices. My a value is the distance that the vertice is from the center. You could have also calculated it or counted it over here. So a squared equals 9. Now, this time, they did not give me, again, any c value. So what I need to do is look and see what my other piece of given is. And my other piece of given is an order pair that's on the graph. And it's the order pair 6, 1. So I could graph that. And your hyperbola is going to look like this. Now, remember, in an order pair, the first number is x, the second number is y. I'm going to be plugging in that x and y and solving for b squared. So again, it's touching my x-axis, so I'm using x squared over a squared, y squared over b squared. And now what I'm going to do is I'm going to plug in the 6 for my x and the 1 for my y. So I'm going to be doing 6 squared. My a squared was 9. My y squared, or my y, is 1. Then the b squared, and then the 1. Now, for this one, we could actually solve this 2 ways. Let me go ahead and first take care of the squares. So this will become 36 over 9 and 1 over b squared. Now, the first way I could solve this, and it doesn't matter, your goal is to solve for b squared. Whatever it takes to get b squared by itself. So what I'm going to do is I'm going to divide 36 over 9, and I'm going to make this 4. Rewrite the 1 over b squared equals 1. Again, my goal is to get this all by itself, so I need to subtract the 4, and I get negative 1 over b squared equals negative 3. Now, I could either add a 1 to that denominator of the 3, the negative 3, or just know I'm going to multiply both sides by b squared to get it out of the bottom of the fraction, and then I'm left with negative 1 equals negative 3b squared, divide by negative 3, and b squared equals negative divided by negative is positive 1/3. Now, what we could have also done at this step instead is you could have left it a fraction and worked with it that way. Subtract 36 over 9 instead of subtracting the 4. I'm going to change the whole number 1 and make it so it has a common denominator. So negative 1 over b squared, and then over here it'll be 9 minus 36, which will be a negative 27 over 9. And now I could just solve this as a proportion. So I get negative 27 b squared equals negative 9, divide by negative 27, and b squared equals positive 9 over 27, which simplifies to 1/3. So either way, it doesn't matter how you go about, but you need to get b squared by itself. Now that I found b squared and I had a squared from just counting the lines, now let's plug it into the equation. So it's going to be x squared over 9 minus y squared over 1/3 equals 1. Now, this format, generally you should not be leaving a fraction in a fraction here. But be aware that this could be one of the multiple choice answers that you could look for. So if that's the case, you can pick it. Keep in mind that each textbook, each test generator may expect to have the answers in a specific format. So it's important that you recognize this because this could be an SAT question. However, what we're going to do here is I'm going to show you another way that we could simplify this. And I believe we saw this with one of the prior lessons. So this y squared, I can assume a 1 here. This fraction bar means division. So really what I'm doing is 1 divided by 1/3. I keep flip change and it becomes a 3. Essentially, all you need to know is if you have a fraction and a fraction, just take this denominator and move it to the numerator. But I showed you why we would move it to the numerator, because we're dividing it and we get 3 as the answer. So another format of this would be x squared over 9 minus 3y squared. You could put the 1 there. However, we're just going to write it as x squared minus 9 minus 3y squared equals 1. So be aware that both of these could be answers. I doubt they would leave it like this with the 1, but be aware that that could be a possibility. Let's try one more with the center at the origin. Again, let's get a visual. I need to graph my focus point, which is the square root of 13. So the square root of 13 is in between these two perfect squares. So I'm going to say it's about 3.6. So I'm going to graph negative 3.6 and positive for this. So it's a focus point. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4. I'll put one of them here and here. So this already shows me that the focus is always on the same axis as the vertices. So this tells me it's going to be a y squared over a squared minus x squared over b squared. This can tell me my C value. So my C value is the distance from the focus to the center. So my C value is going to be the square root of 13. But I need C squared. So when I square a radical, it just makes it go away. The other piece of given information is my asymptote. So we've already determined that the first variable is the y squared. So this tells me the format that you memorize for the asymptote is a over b. So I'm going to take this a over b and I'm going to set it equal to the 5. So I can make it a fraction by putting a 1 in the bottom. Now, notice this time I don't know anything about a or b, so I can't replace it and try to figure out what the fraction was before it was simplified. So when I go to solve this one, what I'm going to be solving for is an expression. So I'm going to do the cross products. So I'm going to get a equals 5b. Now, I need to get both a squared and b squared. So again, I'm going to resort back to this equation. And I'm going to plug in what a equals, which is 5b. So c squared, I already know that, that's 13. My a value is 5b, and I'm going to square that 5b. When I square the 5b, I end up with 25b squared. Notice I have like terms here. I can add them. I can assume a 1 here. 26b squared equals 13. I need to divide both sides by 26. So b squared equals 13 over 26, which simplifies to 1/2. Now, again, remember, we need to find not only b squared, we also need to find a squared. So I'm going to use this formula one more time. I have c squared and I have b squared now. Now I'm solving for a squared. So my c squared is 13. I don't know the a squared. And my b squared is 1/2. I'm going to move the 1/2. I'm going to change this 13 into 26 over 2. So now I can subtract 26 over 2 minus 1/2, and I get 25 over 2. And that is my a squared. So now let's plug in what we know. Y squared over 25 over 2 minus x squared, and then the b squared is 1/2. And it equals 1. Now, be aware that, again, this could be an answer choice on a multiple choice test. However, we don't like fractions and fractions, so what I'm going to do is take the denominators and swing them to the top. So then I'm going to get 2y squared over 25 minus 2x squared over 1 equals 1. And then again, I'm just going to get rid of that 1 that's under the 2x squared. So again, be aware that this could be an answer, and so could this. So just be careful, be able to recognize it. All right, let's try now 2 examples where the center is not at the origin. Jumped over one. Let me go back to 5. So let me graph the vertices. So I have one at 1, 2, 3, 4, 5. I have one at 4, 5 and 4, 1. Now, remember the center is the midpoint of those two. So I have two options here. When your vertices are vertical or horizontal, you can just count the gaps and just find the middle. So I can see that the middle is going to be right here at 4, 3, because this would be 2 spaces away, and this is 2 spaces away. Okay, the other way is you could take those two vertices and you could use the midpoint formula. Add your x's, divide by 2, add your y's, divide by 2. So this gives me 8 over 2. This gives me 6 over 2. So this gives me the same order pair I got by just finding the middle of the two vertices. Now, you can also get your center from your asymptote, because if you recall, we did y minus y1 equals plus and minus a over b, x minus x1. Now, the reason why I put the a over b is because my graph is going to be, it's up and down, it's vertical here. So now what I could do is, remember this x1 is the k, and the y1 is the k, the x1 is the h. Now, notice my asymptote that's given to me, it's not in this form. They've manipulated it. What they did was they took the 3, which was your y1, and they moved it over here in front of that a over b. So I'm going to move it back so it's in the form that you're going to memorize. So now I could also get my h and k right out of my asymptote, which again I could pull out the 4, which is the h, and the 3, which is the k. So that's going to help to give me my center point. Now, again, notice it's vertical, so the equation I'm using is y minus k squared over a squared. A squared's always first in the hyperbolas. X minus h squared over b squared equals 1. So far, I have found the h and the k, and it's this order pair here. This is h, this is k. Now I also found my a value, so a squared is 4. What I need to find is my b squared value. So what I can do, since I don't have I don't have a focus or anything, I'm going to use my asymptote. I'm going to use this a over b and set it equal to 7 over 1. So I'm going to take a over b, set it equal to 7 over 1. But remember, we know the a value. Before it was simplified, a equals 2. So let's go ahead and put that in there. So 2 over b is equal to 7 over 1. I can solve the proportion by multiplying diagonally, and I get 7b equals 2, divide by 7, and b equals 2/7. Remember, we don't want b, we want b squared, so I square, and I get 4 over 49. Now let's go back. We're going to plug in a squared, b squared, and the h and the k. So final answer here is y minus 3 squared over the a squared, which was 4, x minus h, which is 4 squared, and then the b squared is 4 over 49. Now again, be aware that this could be an answer choice, and you could pick it. However, we are going to adjust it and move the 49 up. So another option for the correct answer, first fraction's fine, move the 49, leave the 4, and then this is another answer. Because again, we don't like fractions and fractions. I'm going to do one more example. It's kind of simple because they're giving me a center, a focus, and a vertice. So let me go ahead and again give myself a visual. So let me graph the center first. So I'm going to graph the order pair 1, -2. Next I'll graph this focus point. So 2, 3, 4, 4, -2. And then lastly, the vertice, and it's at 3, -2. So this tells me that my graph will look like this. I could actually probably find the other vertice. I could come over here. I really don't need it. This one's 2 away from the center, so then I need 2 away over here. Now, what I do need to find out is how far away is the center from the vertice, and we could count the spaces, and there's 2. So a squared equals 4. I need to do the same thing for the focus, and it's 3 spaces away, so c squared equals 9. Now, you can already see it's touching the x-axis, so we're going to be using x minus h squared over a squared, y minus k squared over b squared equals 1. Now, the center, they gave me h and k. I just found the a value, so now to find the b value, I'm going back to this equation. I'm going to plug in my c, and I'm going to plug in my a and solve for b squared. So 9 equals 4 plus b squared. I'm going to move the 4 over to isolate b squared, and b squared equals 5. Again, that's what I wanted, so I don't square root anything. So now let me go back. I need to replace h, k, a squared, and b squared, and then I'm done. So x minus 1 squared over 4 minus y, and it's a -2, so plus 2, because negative becomes positive, and then my b squared is 5, and it equals 1. This one didn't have other versions because there were no fractions, so that is your final simplified answer. Homework is on the next page. It's 31 through 41 odd. And that's it for section 10.3.